Hello everyone, welcome to our talk about, what we'll do is we'll look at what happens when you click at a unit in a course from the learning MFE. But before we do that, this is Piotr and this is me, Kaustav. We'll take a brief look at the OpenEdX platform too, just quickly, so that if someone is unaware. So the OpenEdX platform consists of multiple services, plugins, UI components, which are spread across multiple repositories. It's not a single repository. The edX platform repository is, of course, at the heart of it all. And there are also multiple IDAs, which are optional optional services which could be enabled, such as discussion forums, analytics, course discovery, e-commerce services, things like that. The edX platform itself consists of mainly the LMS, which is used by the learners to access the course content and certificates and things like that. It's also used by instructors for some things like discussion moderation, grading, etc. And the CMS or the studio, which is used by the course authors to design and build courses and set dates and things like that. So apart from the LMS and the CMS, there are some common components which are also used, such as one of which is the XBlock Runtime, which we'll be looking at in detail today. So the LMS and the CMS have been quite self-sufficient for some time now, till some time back, where the UI and the backend was all baked in together, but now the UI is rapidly being separated into its own repos, which we call micro frontends. These are React-based projects in their own repos, and they interact with edX platform using APIs. So some of the examples are the learning MFE, the course authoring MFE, the authentication MFE, things like that. So what happens when we take a course? So let's start at the dashboard page. To begin a course, we generally click on begin or resume course. And what that does is it redirects to the learning MFE, the homepage for the course, the URL of which looks something like this, where the course ID is passed. Now, when we redirect it there, it does a bunch of API calls, one of which is the course metadata API. So this is the URL, and this is what the data looks like. So it gives the MFE the context about the course. It is things like what are the course tabs which are available, whether the user is staff, whether he's enrolled. So a bunch of information returned from there. Taking a look at the view, this is the view which basically, if you can see, the course, most of the data is fetched from the course overview module, and it just this is what is returned to through the API. Next important API call is the course outline API, which basically returns a list of the blocks which are available in the course. So taking a look at this list, so it is a nested structure. So first is the course block, which has children, and the children are the chapter blocks, which are basically the sections. Each of the sections will have children which are sequential blocks, and the sequential blocks basically now have nothing, but they just have the name, display name. So this is what is used to, this is the view of the outline API. If you go to the course outline block tree, and if you follow that method, it eventually leads to the get blocks method, where it uses a bunch of transformers. It first fetches the course from either the cache or the module store and applies a bunch of transformers in there, and then serializes the content. This is which is being done through the block structure manager class. Here you can see it mainly uses the cache, but it falls back to module store if required, and then applies the transformers to the block data. This is what one of the transformers look like. It's the discussion links topic transformer. So what it does, it basically is it adds, it creates topic links depending on if you are using MFEs or not, and then adds it to the block data. And once we have that, the MFE can now render the course outline. When we click on the one of the subsections, it redirects to that page, and the first API call, one of the API calls is to get the data for the sequence, and this is what the URL looks like, and this is what it returns. It returns the list of items in that things, which are the units, so this is rendered like this. So all this is well and good, but how is the actual XBlocks rendered? Well, that is not really handled as much in the XBlock. It's just an iframe, and this is it just passes the URL, and this URL is pretty self-evident. I mean, you can open the URL separately if you're logged into the browser, and it will still display the entire unit. We'll now take a look at what happens when this URL is hit. So you can.
Right. Hello everyone. Now I'd like to guide you through what happens when the LMS renders an XBlock, especially in the context of the runtime. So let's begin our journey in the LMS URLs. So here we can find the definition of the direction to the view that renders an XBlock. This view can either render a single XBlock or a whole vertical, which is a set of multiple XBlocks. So this view looks like this. For the sake of completeness, I will say that it is used not only when rendering the XBlocks in the LMS, but also used in the LTI provider when the XBlocks are being rendered in other LMSs through the LTI protocol. What's interesting here is this get blocked by usage ID part. So let's go into this. So this function does multiple things. It transforms the course key into a string, it retrieves the usage key, and then it uses the helper method to get the block from the module store. So the helper method looks like this, helper function, I'm sorry. The most important part here is the call to the module store to get the item. So let's dive in. And now we're looking into a function from the split Mongo module store implementation. Let's take a look at how it loads the items. Alright, so here is the function that loads the items. We're getting there. One more stack frame. And here is what we're interested in. The function that creates the runtime. It instantiates the caching descriptor system, which is the subclass on the XBlock's runtime class. This subclass provides the implementation of its abstract methods and adds additional methods and services that are then used by the XBlocks within the OpenEdX platform. Alright, we'll stop descending into the code here, and we're going to go back up a few stack frames to the function we have already visited, the get blocked by usage ID. Right, so if you looked closely, we have retrieved the XBlock from the module store, but we haven't passed any user data there. So how does the runtime know who wants to view this XBlock? Does it use some cram module to retrieve it from the request or some other implicit magic? Not really. This is what the getBlock for descriptor function is doing. Right, so this function handles preparing the student data within the runtime. So this, yeah, I have spent many hours working on this function. It's been very tangled for the many releases in the past, and I will skip many parts of it because it's huge and it's doing so many things that we wouldn't have enough time. So right now, what does preparing the runtime for user mean? So basically it means initializing all the wrappers. For example, we have the masquerading, we have licensing, we have a special wrapper for the LMS that adds the course ID. And here we have some more wrappers, for example, to replace the URLs. So, for example, if you have a link like /jump to ID /some ID within your XBlock, it will be automatically replaced with a reference to another XBlock. We have also other things like access messages, course expiration, and the offer banner. And yeah, the staff debug info is also rendered in here. So the next step is preparing the services. So what are these services actually? So let's take a step back into the combined system. So in the past, the runtime was split into the descriptor system and the module system. The descriptor system handled things like the code behind editing the XBlock, behind adding some non-user related data, and the module system was related to everything that's been related to users, to the students. Right, so the descriptor system was instantiated at the beginning just as we saw. And then the module system was instantiated as a part of this instantiation, which led us to the combined system, which actually was a wrapper for both of them, which retrieved the attributes and functions and everything from the module system first, and then if it didn't exist, it retrieved them from the descriptor system. So what it meant in practice? It meant that the runtime had to be aware of the XBlock instance it's actually rendering and of the user, the course, and everything like this. So we started working on unifying the module system and the descriptor system to make it block and user agnostic. The first step was converting all X modules built into the platform and installed as the dependencies to the platform to the X blocks. After this step was completed, we could proceed with unifying the runtime systems. The only thing we had to do was to check their initialization attributes and extract them outside so they can be initialized together. Sounds simple enough, right? Yeah, so this is the basic initialization, the basic constructor of the module system. Yeah, so this is only the base class. It also has its super classes, subclasses, sorry. There was the macro descriptor system, the external parsing system, import system, caching descriptor system for Mongo module store, and the one for split Mongo module store, of course, the preview module system, the LMS module system. So we had to go through all of these and extract these initialization attributes somehow to avoid passing them all the time. So this is where the services come to life. So instead of passing these arguments to the runtime, we can now pass at least some of them to the services, which are then used by the XBlocks. But what does it mean in practice? So this is an example of moving the replace URL function from the runtime to a separate service. This one is used in the problem XBlock. So it means that we had to add this XBlock needs annotation, and then instead of using self runtime replace URLs, we just retrieve the service and use its method. So by removing the dependency of specific XBlock instance and the user, we were able to share the runtime between all the, and its services, of course, between all the XBlocks we were instantiating within a single request cycle. It doesn't sound super useful when we render a single XBlock, but when we render a vertical with 50 or more XBlocks, having a single runtime and a single instance of each service makes a pretty big difference. All right, so right now I'd like to pass some kudos. So kudos to edX, Tikrill, and Axim for making this happen by making this a blended development project, and then the funded contribution as well. Kudos to Dave Ormsby from edX, Tikrill, and Axim for lots of help with making this happen. Kudos to the OpenCraft team, to Kaustav, to Arun, to Braden, to Jill, to Usman, who was converting the X modules to XBlocks earlier. Kudos to Maxim, Pooja, Demid, Naveen. I hope I didn't skip anybody. All right, that's it. Any questions?
Hi. So, the question that's running in my head is like, we are looking now at the new mechanism, the learning core libraries.
Mm-hmm.
How much of this code could be gone if we jumped straight into that mechanism? Or is that all staying even if we switch and remove Mongo and do the whole refactor?
Great question. So we could remove most of this code probably with switching to the learning core. This is a legacy mechanism that still supported the old Mongo module store and other stuff. So we had lots of backward compatibility to keep while still we were refactoring this to remove the backward compatible code.
So the changes that you made to move things into the services, it all looks really great, but doesn't that break every external XBlock like out there that needs replace URLs and needs like they're gonna have to update their code? Do we have like did we create a new version of XBlock to say that this has happened?
Right. So every single service that we introduced is also used by the deprecated methods to keep things backwards compatible. So some changes were not backwards compatible because we needed to remove, for example, for the replace URL, we had like the, I think there was a course ID stored somewhere and we had to remove it to just, you know, be able to unify the module system, the descriptor system. But we went through all XBlocks that were installed in the edX platform by default and through the most popular ones and announced the deprecations a bit earlier so that people could adapt to these changes. But most of these changes were backward compatible. We still have some deprecated code to remove after this, but yeah.
This is a minor question, but I noticed there's a lot of services now for the XBlock, and we always initialize them. Is there any overhead to initializing them all instead of doing it on demand, or are they very lightweight?
I mean, The services are pretty lightweight. So some of them are actually partials because some services require the XBlock instance to function. For example, the replace URL service requires pulling the custom overrides for the static URLs or some data URLs from the XBlocks that can be written somewhere. I'm not even sure where it's written, but not really. So the services are rather lightweight classes.
If you had more time to work on this, is there more simplification that you'd like to do?
That's a great question. So with the moving to the learning core, I'm not sure actually if we are at the point where most of the code could be deprecated. So once we move to the learning core, I think it will be the great time to revisit this work and see what else we can simplify.
So now that everything is running through XBlock services, runtime services, do you think that it would be worthwhile to make runtime services pluggable so you can install your XBlock with your own XBlock runtime
Sorry,
services?
I didn't catch the last part.
Oh, do you think it would make sense for us to make it so that runtime services are something you can build externally and like get dynamically loaded as opposed to having a set of preset services in the LMS?
Like the pluggable services, then you can load from external sources.
Yeah,
right?
like if I wanted I don't know, if I felt that I had a reusable service that other people could use in their across a bunch of XBlocks, does it make sense to like have that be a sort of dynamic mechanism, or like have you seen use cases for that?
Not really, honestly.
Okay. Oh, I like that. I like the no answer. I just want to make sure. I'm just curious.
Yeah, I'm not sure what would be the use case for this. I mean, we could have some built-in places to override within the existing XBlocks that could, I don't know, load some external services that are dynamically discovered. But I'm not seeing like the specific use case we could do here.
Well, I just want to follow up on that one challenge with XBlock API is nothing forces you to go through the services API. So you can create a Django app plugin and then just call it using Python directly. And there's not really an advantage to you as an XBlock developer to use the service API. And that's why this accumulated in the first place, actually.
That makes sense. Because, rephrasing. As you are looking through the whole list of services, are there any services that you think don't really belong because they are not generally used for, they're built for some very specific case that shouldn't be in the core platform? Again, no would be a great answer and make me happy, but this is just what I want to know.
Yes, I think we could actually simplify the number of services and move some of this code somewhere else because, yeah, as you mentioned, the list is huge here. So we definitely have some boilerplate code that we could use somewhere else or use from somewhere else. But I don't have any specific examples on my mind right now.
I just want to confirm whether these services are initialized in each request just once, or is it initialized just once in its folder?
Yes, so it doesn't necessarily need to be a request, but yes, it's one per request cycle, or once per a run of an instructor task, or once per, yeah, something like this.
What was the most complicated part of this refactor?
This function. Yes, so there was actually a time where this function was calling another function that was calling back this function in a wrapper. So we had lots of, let's say, fun unwrapping these things.
We did it in 2 parts, right? But we sort of replicated it, but then...
Yeah, actually not in 2, but in like 10 parts. But yeah, there were many things like rebinding the user for the LTI when the user is authorized. We had to move it somewhere else. I think you were working on this, right? Yeah. So I think this part was the most fun of them all.
I just want to do a shout out that I think Piotr might have mentioned everybody except himself, but this is some of the gnarliest, most difficult, craziest code in that X platform. It is layers upon layers of hacks and workarounds and hacks on top of hacks. Magic that undoes magic, that redoes magic. It was crazy. It's not a walk in the park still, but it is much more approachable. It is saying that you actually have a chance of reading it and understanding it and not clawing your eyes out. And it's thank you so much for doing this work and for tackling this, because yeah, this is not only is this some of the hardest work, it's also one of the least rewarding in that you move the needle and nobody notices all the great work you're doing because nobody has to touch this part of the code until they have to, in which case, but no one notices the work until there's a tiny slip and there's some regression in some corner case where somebody did something crazy in content, and these folks had to work through all of that in fits and starts and tiny pieces working to. So this is a monumental effort. It's really hard stuff. Thank you so much for doing this.
And thank you.